Okay, I'm going to make a presentation about the BIOS3D. It's a numerical prediction modeling for the lake water quality in lakes and estuary. And the latter part, I'm introducing a potential linkage between the lake database and the modeling approach in order to introduce several lakes. Right? So this is outlined in the BIOS3D. It's a non-hydrostatic 3D modeling. Which is capable of calculating the velocity, temperature, suspended particle, and water component, inorganic phosphorus and deteriorated phosphorus, inorganic nitrogen and inorganic nitrogen, deteriorated nitrogen, chlorophyll A, and we have cyanobacteria and diatom and other phytoplankton, and COD and dissolved COD and particulate COD and dissolved oxygen. And recently, of course, we introduced several contaminants into the model. So this is the first step of the BIOS3D, and for the prediction of the temperature annually basis. And then the important thing is whether this model can reproduce summertime. And during the summertime, most of the lake high in the surface, very high temperature. And in the winter happen, they are starting the mixing. So this is showing in the vertical section how the temperature increase in the surface part and how the stratification may start and during the summertime. Particularly in the summertime, the only surface part of the lake temperature increase, but the bottom of the temperature remain the same in case of the lake viewer. And this is a comparing study using the field observation data taken by Lake Viewer Environmental Research Institute. It was, in fact, in 2002. It's quite old, but at that time they obtained all the data. So, like it's March, and April, and May, and June, and July. So, of course, there are some difference between the calculation and the observation, but the surface temperature reproductivity might be acceptable. And this is November, and this is December. And this is for the future projection of the temperature. So we set up several hypothetical boundary condition to evaluate the impact, how the temperature rise of the lake water body occurred if we project some particular temperature of the atmosphere in the condition of the end of this century. And we find out some significant increase of the surface temperature was observed, especially in the North Basin. That might be inducing a significant impact of the lake water degradation. We are doing also the calculation of the gyre by using the particulate. This is showing the general calculation of the gyre of the North Basin of the lake. This has been conducted a very long time ago, but showing in the North Basin by the model, it is it's observed anti-clockwise gyre can be formed. But in the same time, in the high premium, there are clockwise gyre produced. However, we have not been able to observe this clockwise gyre yet. This is a vertical section comparison with the current temperature and future temperature. If you project the future condition, the temperature might be very, very high, especially. And then we introduce a chlorophyll A modeling of the lake viewer. But in this case, this model particularly developed in the early 2000s. And then at that condition, the chlorophyll A concentration is dominated mainly by cyanobacteria, and sometimes it's a diatom. But recently, due to the massive increase of the water macrophyte, then the chlorophyll concentration doesn't become so high. So we should develop a different model which compensate the ecological regime shift between the phytoplankton and also competition between the macrophyte and phytoplankton. That is being carried out by our student, Ms. Schwetter. And we hope that throughout the collaboration, we can make the new one that can, considering these differences between the chlorophyll increase and also the macrophyte increase. Of course, we did some comparison with the modeling and observation. It's agreed. But particularly on that topic, I will introduce more by using the satellite image. We are doing also the dissolved oxygen simulation. This was a reg viewer dissolved oxygen decrease. And this model I'm trying to show during the summertime, because of the temperature increase and also because of the organic material, at the bottom of the lake, particularly some oxygen decreasing condition, but it will be recovered in the vertical mixing in the winter's time. So it is very, very important to do it by physically considering this. This is comparing the numerical study and the observation study. This is the future projection, and this is also observation. We do some observation of the lake and try to identify the current status of the lake temperature. And that observation, we carry CTD profiler, and also that is also being developed together with a private company. This map is showing the comparative study of the lake viewer, BS3D, with a calculation in the top and observation in the bottom. The top layer is a calculation with the temperature in the one particular section with the deepest part of the lake viewer, and this is observation, and that follow most of the annual year. Of course, there are some difference between the calculation and observation here, but mostly it reproduced very well. In terms of the dissolved oxygen also, it has been improved in the some section. And we have applied this model into the lake tower, which has 500 meter depths. And the general tendency, of course, can be reproduced. In that case, the bottom is calculation, and the top is observation. The calculated water is a little bit apart in terms of the mixing. So probably we need to fix the particle mixing condition, because the lake tower is very, very deep, it's a 500 meter deep, and it is very, very orthorhombic place. And the dissolved oxygen it's reproduced well, but in normal condition, it is very difficult to predict the potential changes of the lake. We are applying this model into the different lake, but by doing that, we are trying to combine with a database we call it the Global Lake Reservoir Repository that is being implemented in our faculty, Graduate School of Advanced Integrated Study. So we officially launched this global, and together with the Disaster Prevention Research Institute, we are officially launching, not yet officially launching, but we put all the lake data. This is almost 120, but we are trying to get almost 300 lakes. And together with those lakes, and each lake has their catchment area, and also we are trying to get the bathymetry. And by putting those information, we can apply those modeling with a precise condition. For those lakes, we cannot get the profile. Then we can make assumption by using the simplified model, like a one-layer model, or two-layer model, or one-dimensional model, or two-dimensional model. But the important thing is to get the correct data. So each lake has very simplified information. But of course, there are several one-lake databases, but our database is particularly focusing on the affiliation with the modeling and also the calibration with the satellite image, like this form. So, and also we are applying for the BR3D into the lake tower with a collaboration of LIPI in Indonesia. And this is also a particular application of the model. This is a hydraulical part of the modeling. This is in the Tokyo Bay, and we are of course making coupling of the modeling of the hydraulical part and also the hydrodynamic part, and apply for the this is the temperature of the Tokyo Bay. Resolution is not high, so it is just a beginning study, but we can decrease the resolution, of course. So this is a simple conclusion. The BR3D has applied into Reactive and Rector and being used into the Rectover and talk about many different ways. But to do that, we would like to propose the linkage between the database, open access database, and that database that we have introduced is a part of the gem sorter. But in this time, if the UNESCO IHP can make a kind of collaboration with us, then we could run some official database from the lake and collecting all the information and trying to testify some of the modern technology into the different lake. Of course, modeling should be compared with observation. We know several that kind of approach is being implemented, but the important thing is always the database should be considered with a person who is using the data. Right? Thank you very much. This is so. If you have, sorry, I have to read. So if you have any question, okay, please.
Just one quick question. Has your model got reinforcing?
Yeah, of course. Yeah, it is of course integrated with the climate modeling also. But model doesn't calculate the wind. We just get the data from the meteorological data or other modeling output. Yeah, please. Aisha.
Okay, thank you. How complex is the model? This is a 3D model, so what are the parameters for calibration? Because you mentioned that we can use for other reasons also, so probably data scarcity is the main issue.
Yeah, actually, I have a parameter set of 110 parameter, and that calculation is very, very demanding. But particularly, we find out the 4 to 5 parameter is very, very important because most of the parameter is well being studied. So we are using the much resources applied for the different modeling. Of course, that should be compared.
It's a very complex model, so how do you control the boundary condition? Because there can be rivers are coming to the lake.
Yeah,
I know
that is the most difficult part, of course. And now I am putting the river as observed data, and for the future prediction, I'm doing the linkage between the hydrological modeling and hydrodynamic modeling because I do the catchment modeling. But it is on the way. It is we have to adjust in the more appropriate approach. Okay. So, if no question, thank you very much.